here are some steps I had given that you can follow. First, when you start in the beginning, you have to start the new project. So here you can click yes, start a new STM32 project. Then you can select the board, which board, whatever the board you are going to use. You know what board you are going to use. So this is the board version Nucleo 64. You had seen here Nucleo 64. This is your board version. And then after that you have to click the MCU. Yes, you have to first select the board and then you select the MCU version, that is the L476 RG, and then you can type the project name in this window. So in the project name you can give whatever the name you want. For example, this is going to be the LED blinking project, so I had given that name as a Nucleo hyphen L476 RG hyphen blinky, and whatever the name you want you can give. And here what targeted language you want to use, you want to generate from this tool, so you can choose C or C++. So I have chosen C, and then of course these all are, you can leave it as a default one. So this is executable, then binary type, and then this project type is STM32 Cube. So and then you just click finish. Yeah, this is what I had given. Then it will ask you, do you want to open the perspective now? Like this. Oh, I didn't give the print screen of that. Yeah, then you just click yes. Then you can do the, it will ask you, this is the first question, and then second question, it will ask you default initialization of peripherals. So you, because you are a beginner, so you better click yes. So you will keep all the peripherals initialization as a default. So especially this is a demo board, so you just click yes. And first time when you create the project, it will ask you sometimes, or it will take some time for IDE to download all the associate files for the clip or for the chip or board. So as I said, like you are already connected your PC to this hardware somewhere. So you are selecting the which board you are going to use or connected to your PC, and then you are selecting the board and then the version of the MCU, and then you are giving the file name, and then you are clicking finish. So the first time it will take all the necessary supporting files from this tool and then download into the microcontroller. So it will take a few seconds or maybe one or not more than a minute, and it will prepare the microcontroller to download the programs. So that is why it's supporting all the necessary files into the chip or the board. It means you need internet connection when you install first time. So you cannot do this installation in offline. You must need internet connection. So you have to be online to do this process the first time. Once it's done, then you will see a graphical tool of the microcontroller. So it will be like this. You will see this page. So here you will see the microcontroller and then all the pins, input output pins. So here in the left side you will see some other categories where you can change if you want some other possibilities. For example, you can change the connectivity, or you can change the security and computing and so on. And remember this tool, STM32 CubeIDE. This is an integrated tool which can generate the C code, and also it can edit the C code. You don't need to have a separate IDE, and you do not need a separate link driver. So during the installation, it will already ask you to install the link driver. You just click in the box yes, then you will have the link driver. But in the other tool, as I told you, you have to download separately the link driver and you have to install and then connect them. But here you don't have such a process, so it makes life much easier, this tool CubeIDE. So you can decide which tool you want to use, either CubeIDE or CubeMX together with KLU Vision. So there is also ARM OS and RTOS, that is the ARM operating system and real-time operating system. This STM32, the version you are going to use, the L476, it can also support this RTOS. So that is the real-time operating system. If you need in some projects, you can download this also from STM website, and you can use this together with this microcontroller. So you can explore more by yourself. What is this RTOS and how can you use this together with this microcontroller? So you can use, or you can select whatever the tool you want to use. So you can see all the peripherals, all the available peripherals for your board on the left side, and under categories. For example, here you can find the ADC, DAC, and other. And here you can see the timers and so on. So you have to select which one you are going to configure in your microcontroller. And also there is another possibility. You can click directly on this pin, because you can see several pins, right, in the left and right, top and bottom. So you can click whatever the pin, you can just click the left click, and then you will see a box. Let's see here. Yeah, you can see here. So if you click this one, for example, so you will, for example, now I click this PA8 pin number. So if I click the left click, if I make left click, then I will see here. So I can set up this pin for what purpose I want to use. So for example, now I want to use this one for the timer channel one. So I can click this one. Then this will be assigned to this pin. Similarly, instead, if I want to use this as an input pin, so I can choose this GPIO underscore input. Then this pin will be assigned to use as an input pin. Similarly for the output, if I want. So this is for selection. So once I click, then it will automatically turn into green color, and then it will be showing. For example, this one P13 I used for timer TMS. So if you scroll down, you can click this TMS, and then it will be like this. You can see this pin. So whatever the pin number I assigned already, something some of the pins are already default assigned by this. You remember you clicked the default settings here. So I asked you to select default initialization of peripherals. So we clicked yes here. So these all are already assigned or initialized by default. So if I want to change, I can just click left click on this pin, and then I will have this box, and I can change the function of this pin to something else. So each pin I can configure like that, whatever the purpose or function I want to use the pin for. Yes, so this is the same thing. Left click on pin PA8. So we can set GPIO underscore output by a simple click. So if you do it again, then you will disable and bring back the two default pin. So what it means, if I click this, for example, where is the GPIO output here? So I select this one, then this pin will turn into green color, and then it will be showing this GPIO output here and with this pin. And now if I want to change it again, then I just left click again, and then I will see this box. I click again on the top of this GPIO output, and then it will be disabled. Then the pin will go back to the normal. So this is how you can initialize each pin according to what purpose you want to use it for. So this, for example, you want to use this for peripherals, you can use it for, or USART, you can use it for, or input output, you can use it, or analog, you can use it. So it's up to you. Or this is for external interrupt, and this is for event out. This for clock, crystal clock, real-time crystal clock, so on, so on. So many of the peripherals are already defined for us by default. So this is the same tool. This is the page you will see after you open the CubeIDE. So here you can see CubeIDE. So you will have several tabs. This is the pinout and configuration. This is the home page kind of. And of course, you can also change to other tab. If you click the clock configuration, then you will see this clock diagram. So where you can see the, you can set up the clock speed. So you remember we had seen the clock speed in the last lecture, what kind of clock speed we can use and so on. So remember that on the top we have several tabs. As I said, clock configuration tab will show a schematic of how all clocks, dividers and multipliers are connected. So if you see this, you can see that the same clock diagram or clock schematic you will also see in the data sheet. Data sheet will have some more information and theories that will help you to understand more. So because this clock schematic is particularly for L476. Why? Because here you have selected the board. Remember, so you are creating this project for this particular kit. So here you are selecting the correct nuclear board. Here is the board selection. So you are selecting the board and then the MCU. So you are selecting this one. That's why you are seeing the corresponding clock schematic. But here, if I choose something else, so here in the board selector, if I choose the STM32 F103 or any other version, then I will see the corresponding clock schematic. So it's up according to whatever the board you want to select. You can also use the shortcut here, search box. You can type the version number, then it will show the board. Either it's a Nucleo 32 or Nucleo 64 or Nucleo 144. So this is the clock schematic for this MCU, and you will see, and here this is the clock signal value. You can change this one, and you can change the prescaler also. So I will explain about how to change the prescaler and how to change the clock speed in the next lecture next week. So for us, we do not need to touch this in the initial project. We just keep the default configurations as it is. Of course, this is a demo board, this Nucleo 64 board. So mostly you do not need to change much about the clock configurations. But of course, if needed, you need to change. I will tell you why you should change the prescaler and how it helps. So this is the clock configuration tape, this one. Now, if you click this project manager, then what happens? So it has a default settings such as project name and the location, firmware package, etc. So this one, you already select this when you create the new project. But again, if you want to change or if you want to manage, then you go to this tab, project manager. And then if you want to change the project name, you can change it. So here I put this one, as I showed you in the previous one. And this is the location I prefer to have. So after you generate the C code and after you edit, the program works, the source code will be located in this location. So for example, I have this under the C colon under my username, and it's located in this workspace. My directory is located in this location. It has advanced features such as calculator that we had seen. This is the tools. If you click these tools, then what will happen? So this is the one is helping us to calculate the power, estimate the power which is used by your microcontroller. So maybe you do not need this at this moment, but you can explore this more. So these are the 4 important tabs that you will be experiencing when you open this tool, STM CubeIDE. So pin out and configuration, the home page, there you will see the microcontroller as a graphical tool in the graphical tool, and you will see all the pins like this, and you will change the each pin configuration. And the second one is the clock configuration. You will see here, so where you can change the prescaler value. And this is the project manager where you can edit the project details. And this is just for some power calculation. This is another tab tool. So that's all about the basics of this tool. So now I want to generate the C code. How can I generate the C code? So in this tool, CubeIDE, the left side top, you will see file. You click the file and save, and then it will ask you, do you want to generate C code or do you want to generate code? So do you want to generate code? Yes or no? So you click yes. Then of course you will generate the C code. So it will be like something like this. So you'll be generating C code. It will have several files. So you can see here, these are the source code generated by the tool, and we are only after the main.c. So for example, this you can see here. This is the main C program. This was already generated by the tool. So here you can see all the initializations was done by the tool. I don't need to type everything by myself. You don't need to type everything by yourself. And here you can see the while loop. Mostly in the main program, you will have the while loop. So where you can type your user code. So for the LED blinking, I have typed these two codes. So I have initialized this Hall GPIO pin to toggle, and I have set the delay as a 1000 millisecond. So it means like every 1 second the LED will change, it will blink. I will show you here in the PowerPoint. Maybe it's yes. So there will be so many files, but you only look at main.c, at least in this project, in this first one as the starting project. So scroll down more and find main. Actually, of course, here you have to just go down and then find the main, which begins the programming, and you will find the while loop. Yeah, just never mind this one. So this is a while loop. Usually users put their application code just before while loop and execute for our stuff inside this while loop. So here you can see in each in the file you have several locations. They have a comment line. It's called user code begin includes, user code end includes. So it means you have to type your C code in this between this here. So here also for this private type definitions, if you want to define some other variables or declare any extra variables, then you have to use bit in this location. So here you can see user code begin, user code end. So similarly, and you can find this in different locations in the main program. This is the main.c. This is the main program body. So usually users put their application code or setup code in this location. And explore more into the source code. So you please follow the procedure what I am telling you now. You first install this tool CubeIDE, and then you in the first project you choose everything as a default, and then click file, save, and then you generate the C code and open the C code. It will be like this. And of course you can also see the how GPIO pins are initialized. So if you just scroll down, you will see how these USART are initialized, and everything you will see here. So inside this while loop, if you want to write some application code around the while loop, you can see here user code begin while and user code end while. So you have to write your code here somewhere. So let me show you. So here is the while loop, right? So this while loop, it's giving me option to start my user code. So I started immediately here. So I put 2 front slash. So it means this program will not consider this as a executable command. It's just a comment. So you should know the command and comment difference. So I just put test1 Manikandan, and then here I just write my code, and this is the end code. So end of the user code end while. So where you have to write your C code, you should remember that you cannot write wherever you want. So for example, here I write test 1 Manikandan, and this is the place where I can write my while loop condition. So, and then here outside of this while loop, I write another comment. So there is a test 2 Manikandan. So now what I do, again, I will save file and go to pinout and configuration tab. So, and then I will make the pin PC8. Remember the PC8. So I just change as a GPIO output. So the same here, as I said, like this PA8, I change this to the GPIO output. And then I generate the C code again. So whenever I make some changes, then immediately this asterisk will come, this small star will come. So it means like the main program got changed. So for example, now I make some change. So you can see here, there is a small star, you're able to see. So it means I make some change already. So it means I have to compile again. I have to save again for my changes. So that is what I mentioned here. So what I had done here, just for testing, I have created some line within this loop, the condition given by the code, and then I created another comment outside of this loop. Then I try to save and generate the C code. So once after I save and generate the C code again, I do not really see the C code here. This is empty, the code I wrote. So I can see only whatever I wrote between this loop. So whatever you write, it will not be considered. So you have to write always the code within the allowed area. Okay, so first time when you begin to work with the microcontroller, you may have some doubts and errors. Of course, when you practice more, then your experience will help you. This is a very easy tool, very easy to learn. So if you go to project manager, yes, in the tool, you will have the project. If you click this project, then you will see the project manager. Then you click the C++ build settings. Then you can see that it uses a new tool chain for STM32. So here, you can see here. So you just to go to this project, and then you have to go to the C++ build. And here you have to go to the settings. Okay, here I already have compiled, so I am not going to rebuild again. So just you can build the project again. So once you build the project, then you will see this tab, and if you want to change anything settings, you can click the settings and you can change the settings. So this is just how to use this tool. That is the goal of this part. And if you visit ARM website, it shows a good review overview of how libraries work together. Remember, we are also going to work with the whole library. So you better just go to this link and browse through this ARM website and get some more detail. So it shows more detail about common microcontroller software interface standard, that is CMCs. I showed you the theory why we need these CMCs in the last week lecture. So please try to go through the lecture note again, and also or maybe you better directly go into this ARM website and see what is this CMCs and why do we need to know about this. So each microcontroller have different registers and peripherals. That's correct. But STM32 handles little easier and much of the steps for us because of yes, because we are following this CMC standard. So it helps us in an easy way to learn the tool. And if you write HAL code for one STM32 microcontroller, it should be able to run in another STM32 microcontroller. So that is why I said, like, either we use L476 or F103 or any other microcontroller, the working principle is the same. If you write the code for one microcontroller, you can also use the same code here. But of course, you should remember, when you use the tool, you have to be very specific on selecting the microcontroller. This is about the hardware abstraction layer code I'm talking about. Okay, so the code portability is important. That is why we are having this CMSIS standard. Okay. So, however, most of the HAL documentation exists within a series of PDFs published by ST. So, all the hardware abstraction layer code documentation is available in the ST Microelectronics website. If you go into the website, ST Microelectronics website, so here you can see st.com, you will see plenty of PDF files that you can download. Of course, you don't need to go through all the PDF, but you have to download this HAL for this L4 series that you are going to use in your final project. So STM32 L4 hardware abstraction layer PDF, please download it. You will also need that during the programming. So you need to refer this PDF sometimes. So I had also given the direct link to download this. You don't need to use this link. You can always Google it. It's very easy. It will show the peripherals in alphabetical order. Of course, if you open this PDF, you will see all the peripherals in the alphabetical order. And now we want to blink LEDs in this first project. So look for GPIO section, that is the general input output section in this PDF. And then we just want to find HAL_GPIO toggle pin. So this is what we need. We are going to use in this project because this is for the LED blinking. So LED blinking corresponds to this pin. So it seems we need to give port letter and pin number. So you have to, especially I had given the page number, and you can refer where can you find this one, since this is the first project. But later on you have to find by yourself where can you find this kind of detail for your programming. So you have to everything is very clear. They have the contents and they have even the hyperlink. You can just click the hyperlink, then you will go to the corresponding page. So if you go to this page number 301, remember there are several versions they have. So I used this total number of pages is 1884 pages. So in this document, you go to this page number to find this information. So it also has a halt delay function. So this is another command so that you have to use in this LED blinking project that will help you to make waiting between the toggle. So we are toggling the output pin. So the LED will blink on and blink off, blink on, blink off. So how long it should be blinking? So you have to set up the delay. So for that, you have to use this command. So this is available in page number 79. So you can also use the Control F in the PDF. Control F. If you click this, then you will have a search box in your PDF. The same standard search. You use the keyword. So you are looking for the HAL delay. So you just put HAL delay or just delay. Then it will show you so many delay. Then you have to go to the correct page. There are so many ways to find this in this PDF. So this is important. Please try to download this and explore this. So now we generated the C code based on the initial default initialization. And now what we are going to do, we have to edit the C code. So now go to the IDE and .ioc file and see the graphical tool. So you have to, so for example, here you can see .ioc. So that will show you this graphical tool. That is what I mentioned here. Yes, go to this .ioc file and see the graphical tool. See port number PA5. So whenever we see something like this, it indicates port A and then pin number 5. So here you can see port A, pin number 5. This is I used for the LED, green LED. This is for LD2 because there is also one more LED. So you should remember which LED you are targeting. You are going to toggle. So I am going to toggle this LED, LD2. So I assigned green LED. So I just the same left click and then you will see the box and then you have to assign this for the LED. So and you should know the name. How can we name this? For example, this one TC4, right? So it means it's indicating port 4, sorry, port C and pin number 4. Port C, pin number 4. So for each pin, it has the meaning for that the same. So port A, port B, port C. So here port A, PA5 is connected to the green LED on the nucleo board. So by assigning this, so I have the practical board which is connected to my PC. So I take the pin number 5 in port A for this LED. So that is how I configure here. And now I go back to the C code in main.c and under while loop, type the C code. So now I have to type my application code. So I just type like this. I told you where to find this one, but this is just like a C programming. So this one you should know how to do C programming, and you have to find the correct keyword from this hall file, and then you are just typing this is the keyword hall underscore GPIO underscore toggle pin, and then I put this GPIO A comma GPIO underscore pin A. Remember this is a port A, this is pin number 5. I set up the delay 1000 millisecond. If you want, you can change or you can type whatever. You can put 2000, 3000 or 500. You can set up the time by yourself. That's all. I write the code. So now I go to the project and then build the project, and then I click the run. So you have everything here in the tool. So here you have the run button. So you have to click run and then click debug OS. Then you have to select this STM32 MCU C++ application. So I will show here debug OS. So here is the tool. So I just go to the run and then debug us, and then I click this STM32 Cortex M C++ application. So that is what I had given here. So you have to click this. So now you leave all the settings as a default and the new pop-up window, because it's automatically set for the nucleo board. So you don't need to change anything. Only you have to do this one. After you finish that, then first time when you do this tool, when you use this tool, it may ask you to upgrade the firmware or so you click yes, then you will update your firmware and download into your hardware. Everything will happen automatically. You just have to click yes to update the firmware, and then it will also ask you to this window, this kind of launch is configured to open the debug perspective when it suspends switch. No, so you click switch, so you will open the new Eclipse perspective. So you just click yes, and then what you had done is just only you wrote this 2-line code. Now you will see a new toolbar. Now it will redirect you to the main page of the tool. So here you will see the new toolbar that you did not see before. So here you can just, if you move your cursor, it will show resume 8. So, sorry, this is wrong spelling, resume. So you just click this one, click play button. This is a play button actually. So then now you should be able to see the green LED blinking in your hardware nucleo board. So what we have done here so far, we have generated the C code for a specific microcontroller and the specific board version, that is the Nucleo 64. And then we edited the C code, the main.c. We inserted the code. So here we inserted these two code into the program. So here you see here. So this is the while loop. I have inserted these two code. And then I just build the project, and then I run the project, and then I play. And then when I play, then the LED start to blink. So this is a very simple and straightforward project that is your first project in this course. I will upload this assignment, and you have to practice this. Of course, you have to first install the tool and blink this one and upload your source code in Canvas. So now you should be able to blink this green LED, that is LD2. Remember, we assigned LD2, LD2. Where is that? So I showed just before somewhere, yeah, here. So LD2, we assign here LD2. So in your hardware, the LD2 LED will blink. That is the green one. So on for 1 second, because I set up 1000 millisecond. And then it will be off for 1 second. So yeah, so you can change the delay also, and then you can see if it changes or not. So now our code is running on the microcontroller. So once you've done this, when the LED start to blink, it means you already downloaded your firmware into the microcontroller and it's running on the microcontroller. So of course you have some other options. There are some more buttons that you can explore by yourself. You can click pause, and you can also go to the you can insert the breakpoint into the C code, and you can execute one by one the line, and you can see if you have any errors or if you need to edit any errors. So that is also quite easy. So I recommend you to watch this video together with, in addition to our this one. So this also explains the same what I am explaining here. So yes, so there are some more options where you can how can you handle this main.c in a more efficient way. So then of course, yeah, so whatever the changes you make, you can you have to save, and you have to compile, and if there are any errors, you have to edit. So this is just like a step into and step over function that you can also go into this in the code. You can use these functions. This is also explained in the video, so I do not repeat the same thing here. So this is the compiler where you can insert your code, application code, and then execute and download into your microcontroller and see how it works. Okay, so I think now you can play again. Yeah, so this is whatever the changes you make, how to run again, and then how to download the updated C code into your microcontroller and check how it works. So just follow these steps and you will be able to do this project. It's a very easy and straightforward one.